Yeah, good afternoon to all present here students. I hope I'm audible to all. So you can put on the chat box if you have any query, and let us begin. So far we have discussed the very important part of the simple random sampling, where we talk about the unbiasedness. Then we have discussed for the variance. Then we have discussed some efficiency, which one is better, and then we have seen some confidence interval when sample size is small and sample size is large. That all talking about basically a random variable. So if we have random variable which is a called quantitative type, then we can discuss those things. But what happen if it is qualitative type? Qualitative type in the sense that if you see the question, when somebody asks whether would you like to have coffee or tea, okay, so so, so this type of questions arises whether it is yes or no, okay. So these type of questions are basically called as the qualitative type of variable. So whenever it is a qualitative type of variable, we can't we can't find out their estimation. So in that scenario, how to estimate the parameter? Okay, so for this, in that scenario, we will always go for simple random sampling for attributes. So in many situations, if you see the characteristics under study, it's called as observation which you have collected is basically a qualitative variable. If you see, this is the qualitative variable. Okay, so if you have the qualitative variable, then how you dealing with such a situation? So for example, if the response of the customers in many marketing survey is based on actually yes and no. So whenever the response of the customer is yes and no, or agree or disagree, okay. So in this scenario, you must have some objective. Okay, so what is the objective here? So if you see this statement, the objective of the survey, the objective of the survey is to be estimate the proportion, very important, proportion or the percentage of the, maybe let's say, the brown eyes color, then unemployed person, graduate persons. Okay, so whenever we are interested to obtain the proportion or percentage, so we are go for the attributes. So this is basically, it is not easy, but if you see the criteria which I have given in the notes, you will feel a little bit different from the your simple random sampling. So here the first question is arises here. First question is arises how to do the sampling. The question is that how to do the sampling. Okay. And second question, how to estimate the population parameter. These two questions arises in the case of when we have a variable which is qualitative. Okay, so these two questions, to answer these two questions, we always go for the attributes concepts. So here, if you see the conceptual thing, the qualitative characteristics are based on the population. Qualitative characteristics can be based on population and can be divided into the two mutually and exclusive classes, to mutually and exclusive classes. Say C and C, you can call C dash or you can call C star. Okay. So if I'm saying if we ask some customer, do you like this product? So customers say either yes or they say no. Okay. So they are actually mutually exclusive events. They are actually the mutually exclusive events. So we say yes, we say no. That's why C and C dash or C star. But what is the C? For example, C, this C is a part of the population person saying yes or agree. So if I'm saying yes or agree, we always go for C. And with the proposal, whatever the proposal means, if I'm asking about would you like to have, what would you like to have? So they will say coffee, tea, etc. Okay. So in that scenario, the proposal will be given to you. And C star is a part of the person saying no. So two things you have to understand this concept. C will be representing part of population which is saying yes. Part of person, you can say part of population saying yes. And C star will be just opposite. But if I say let's say let this A be the number of unit in C. Means in C, so so there are few person who's saying yes, some person is saying no. So if I'm saying A is a number of unit in C, so remaining units are will be capital N minus A, which will be in C star. So these concepts you have to just understand properly. So if I'm saying A is my number of unit in C, then remaining units will be N minus A. Okay. In the population of a size capital. So I'm assuming in capital N, I have a population of size capital N. Out of this capital N, I have a unit C. C is saying C is representing yes, but that unit is that particular number of unit which is in C we call A. So in that number of units, so if I'm saying I have capital N units, out of that C is my saying yes, and this unit is represented by capital A. Okay, so whatever the units are available in C, that is representing by capital A. Okay, similarly we have capital N minus A, which is representing so if I say N having these S or S star, C or C star, so if C is representing capital A, so remaining units will be N minus A. Okay. N minus A. So N minus A unit will be always opposite of this unit. Okay. So if I'm interested to find the proportion of units in C, okay, so in C I have capital A units. So what could be the proportion? So proportion become capital P is equal to capital A upon capital N, because we have capital N units. Out of that, A is representing yes. Okay, A is representing yes. So P is equal to A upon capital N. Similarly, if I'm interested to obtain the what will be proportion of C star, it is going to be we called as Q. Okay, we called as opposite of P. This is opposite of P become Q. So Q become 1 minus P. This is general formula, right? We call na P plus Q is equal to 1 in case of binomial distribution, something like that. So we can call this as a capital P representing the proportion of saying yes, and Q which is representing which is saying no. Okay, so how to find the what would be the probability, what will be proportion? Capital N minus A upon capital N, which is representing the proportion which is capital N minus A, capital N minus A. Okay, now if you more dealing about this, if you see this, now here we have to define indicator function. Now what is this indicator function? Okay, basically this indicator function representing that some unit in C. Okay, that unit can be anything. Okay, that unit can be anything. So what this indicator function says, now here I'm defining this y. Okay, so this y is actually my representing the indicator variable. So what this indicator variable says, yi is equal to 1. Okay, that means it is presence if the condition is given, if ith unit belongs to C. Ith unit belongs to C means this ith unit means it can be 10th unit, it can be 5th unit. Okay, so yi is equal to 1 if ith unit belongs to C and is equal to 0 if ith unit belongs to C star, or I may say ith unit remaining units belongs to C. That is also fine, but here I have mentioned C star means remaining units belongs to C star. Okay, so this is a basically indicator variable, and the whole criteria we have to do it based on this indicator variable, based on this indicator variable, which is important conceptual for based on y. So this is a very important part, you can say, because the whole thing will be based on this criteria. So if I'm defining yi, so yi is my indicator variable, which is basically a characteristic under study, and it says whether the particular unit is belonging to C or it is belonging to 0, that is C star. So when it is belonging to absence, it's become probability, its proportion becomes 0, and if it is belonging to C, it's become a probability become 1. So now I'm interested to obtain what could be the total value, what could be the total population. Okay, so how to get this total population? So let's say we have a summation of, we have here summation of yi. Okay, so this summation of yi, basically this summation, if I'm talking about summation of yi, what could be that? This summation of yi, basically if I'm saying, but why I what this yi represent? This yi represent either 0 or 1. Okay, either 0 and 1. So it could be 1, it could be 0. Okay, it could be 1. Just a minute. Oh, shit. This problem will happen always. Okay, so either it can be 1. So you can read from here. Either it can be 1 1 1 0 0 1 1 0 0. So you can, because it is, see, if I have a high, if I have 100, let's say if I have 100 population, somebody say yes, somebody say no, somebody say yes, somebody say, and so on, right? It will be continued till 100th observations. Okay, so out of these observation, if you just collect 1 1 1 1, and what is 1 representing? 1 is representing a time, correct? So if you see this expression here, 1 is representing a time 1. So remaining n minus a time representing 0. Okay, so if so in that case, the probability of representing n minus a is 0, and here a is representing a time representing 1. So that's why the probability become, total value become 1. A means total unit is a. So summation of this yi is equal to a. Is that clear or not? Let me uh, explain once again. Suppose you have a 10 observations, capital N will be 10, and if I ask you uh, one questions, maybe in a form of yes or no. Okay, somebody say yes, somebody say no, somebody say yes, somebody no, 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 yes, yes, yes. So I'll collect all yes together, and that all S represented by unit A. Similarly, all no represented by n minus a. But I know n minus a unit represented by 0. Okay, so that proportion becomes 0, and the unit a, that is ith unit, belonging to probability 1. That's why it is 1 into capital A. So that a is repeating 1 time, and remaining units repeating 0 time. Okay. Then we have a once you are knowing total, I know you everybody know the population mean become y bar, which is equal to a upon capital N. So this you call, this you have already defined, it is the capital P. We have just now seen here. Okay, this is the a upon n become a upon n become a capital P. So we can define. So y bar become capital P. So that is one result you can always know. Now same thing we have to proceed for. Same thing we have to proceed for small sample. So if we have a small sample, then what could be the value? What could be the small y bar value? So similarly, for a small, for here we have mentioned capital A. Here we will mention the small a. Small a will be the number of unit in C, which is fall in C, and remaining n minus a unit fall in C star. Okay, so these two things you can always remember. Small a representing small a belonging to C, and n minus a unit belong to C star. So one can get directly this value. Okay, one can get directly this answer. So proportion one can get easily. So once the proportion becomes small a upon n. So sample mean, it's very simple. So you can get the sample mean will be small p. Then here we have now one can find the summation of yi square also, because we are interested to find variance also, right? So in that scenario, you can always go for the, we can always go for summation of yi square. Similarly, yi square can be written similarly. It can be 1 square, 0 square, 1 square, 0 square, 1 square, 0 square, and so on. Okay. So similarly here, if you see this value, a is repeating 1 square time. The 1 square become 1 only. That means a is repeating 1 time. Similarly, n minus a repeating 0 square times. So 0 square is 0. 0 multiply this time becomes 0. Okay. So again answer is going to be a only. Summation of a and summation of ai square is going to be same. But what about this capital A? Capital A you are already knowing it is n into capital P. Capital N into capital B from star. So where this is star, you can just make somewhere star like this. So this is star. From star you can get the capital A. Capital A become n into P. Then we can write here this capital S square, capital S square, and small s square. Now you know what is capital S square and what is small s square in terms of P and Q. So to express this two terms in terms of capital P and capital Q, because we are interested on proportions. So what is your capital S square, which is your population mean square. So population mean square is become, according to the definition, the formula is n minus 1 summation yi minus y bar ka whole square. Now this is the one formula, and this can be written in another way. Okay, so this is another way of writing the formula. This formula is already, you are already knowing this. Okay, but I have just now, we have found here this summation of yi square is become a capital A. We have just now we have seen this n will be as it is, and y bar we have shown that it is p. Okay, y bar we have shown that it is p. Since this y bar square, it is p square, and we have proved here a is equal to n into p. Just now we have seen, and this will be np square as it is. You can pull out n out, or you can pull out np out, whatever. Just do the simple calculations. If I pull out n, it's become p minus p square. Okay, p square. And again if you pull out p, it's become 1 minus p. So 1 minus p become a q. So this is the q. Okay, so here you can write q is equal to 1 minus, and once you'll be just adjust the term, and if you write it down, it's become n upon n minus 1 p q. So similarly, in similar fashion, you can write small s square is going to be small n upon n minus 1 into p q. Okay, in similar fashion, because instead of because it is a sample mean square will be the same formula here, only the difference is, what is the difference here? It is going to be 1 upon n minus small n minus 1 summation yi minus y bar ka whole square. Okay, in similar fashion one can obtain these expressions also very simple. Okay, simple way you can just obtain the formula for these ones. Then we have now, so this is the, actually we have just do the little bit calculations, and now based on these calculations we have to go for Now we are talking about under SRSWR and SRSWOR. That means we are talking about the unbiasedness. Okay. So we have to first show that this small y bar is unbiased estimate of population mean, that is capital Y. Okay. So to proving this result we already know in the case of SRSWR. So if I want to prove sample proportion is unbiased estimate of population proportion, then how we can proceed? Okay, so I'm using this result, and based on this result, I'm trying to prove that sample variance is unbiased estimator of population variance. So usual you can say notations: expected value of small p. This is small p. Okay, this is a small p this is equal to expected value of small y bar, because we have proved that this is equal to this one. But what is small y bar is equal to summation yi upon n. Okay, you can pull out summation out expected value of yi. What is expected value of yi? N into y bar, right? Small n into y bar. Because we have proved this result we have proved. I think if you just remember the we have shown that expected value of yi is equal to capital Y bar, and I is running from 1 to n, so it will get cancelled and we are turns out to be capital Y bar, hence it is equal to capital P. So one can say that P is unbiased estimator of population mean. Similarly, you can find the variance. The variance of P is going to be variance of small y bar, and variance of small y bar, you know the formula for variance of small y bar. Please read all formulas, because that is all important for us, because if you don't know the formula, you cannot you cannot do anything in that scenario. Okay, always read the formula. Then we have here, you can just substitute the values, and because we have already found the what will be the n minus 1. So s square, the value which we have already obtained, it is capital N upon, this is capital N upon capital N minus 1, because s square we have already calculated here. This is already we have calculated s square. So s square will be N upon N minus 1 PQ. So that you can get directly. Okay. So you can just substitute here, and you will get simplified, you will get the PQ upon N. Similarly, one can find their estimate of y bar. So estimate of y bar, the formula is s square upon n. But what is your s square? It is n upon n minus 1 pq. So you can get cancelled. So again the variance of, this is the estimated value of variance of p under with replacement. This is under with replacement. So that is important part. A similar condition you have to use for WOR also. Exactly same procedure. Okay, exactly same procedure how to prove that sample mean is unbiased estimator of population mean. So this is also same, this is same. Now here the derivation is little bit changed. That was n minus 1, okay, according to formula. Now it is n minus small n. That only difference is this much, otherwise the whole derivation for variance is going to be same. Even for the variance of y hat under WOR, it is n minus 1 in the previous case. Here we have n minus small n. This derivation is going to be same. Okay, so I'll stop here. Let me ask if we have any questions. So if you have any questions, you can put on the chat. You can put on the chat box if you have any questions, or you can ask directly. I have unmute to all. No questions so far. 36 students joined so far. Okay, so this is the very important part where we're dealing with the qualitative variable. So go for always qualitative. So let's proceed. So if you see the population, we are talking about here population mean. Okay. Now sometime they will discuss population total. So there is not much difference. Population total become just you can apply the population total become capital A. Okay. Because we have defined here y is equal to summation of A is equal to summation of yi. Okay. A is equal to summation of yi. So one can go for directly A hat, which is n into, capital A is equal to what? If I'm saying capital A is equal to capital A is equal, just a minute. So here if you see this, here we have A is equal to, what is that formula? N into P, right? Then what could be hat? Your hat become A hat is equal to P hat, right? But this is equal to what? This is capital N into small p. And once we have capital N into small p, you can always see these expressions. Okay. So small p become what? So once we write so many things, it goes. Just give me a second. So once N into P hat, so this N into P hat become a small a. It's your small p become what? It is A upon N. It is A upon N. So you can simply write here. It is, what is that? It is A upon N, small n. Okay. So you can go by this. Then similarly you can find variance of this. So variance of A hat is nothing but what? According to this formula, it is n square. If I pull out, it is n square because it is variance. When you pull out, it becomes square. So n square into variance of small p. And if you're interested to find estimates, then you can simply put one estimate. So it is estimate variance estimate of A hat is equal to n square variance of p. Now you can see this variance you have already found here. If you see this, can you see this variance you have already found? The only question is that whether you're talking about WR and WOR. Okay, so these two things you can just take. It is based on the problem. Okay, so hopefully next week on it we'll start the practicals also. So let's see whether once we will get some notifications from our head of department, we can start practicals also. I'm going to share the practicals in GC, so you can just take down those practicals and you can start write down those practicals in the book also. There is no problem. Okay. So now we don't have any practical sheets so far, so that is not a problem. You can start in the book. Now we are dealing with the confidence interval. Okay, so similarly confidence interval which we have discussed last time, same procedure you have to do it here. So now here we have capital N, we have a capital N units. Okay, this is the capital N units and we have a small n units, assuming both are large. Okay, because capital N means it is going to be definitely large, but small n also we are assuming it is large. Okay, so that means n is greater than 30. So if n is greater than 30, then we know the very simple way we are going to apply Z distributions because the sample size is large. Sample size is greater than 30. So usual confidence interval we already know it is minus Z alpha by 2 less than equal to Z. So this is your Z, which is equal to this less than equal to Z alpha by is equal to 1 minus alpha according to the formula of confidence interval. Okay. So you can just get simplify these all and you can just get multiply, get simplified, take p will be that side of everything. After simplifications, we got small p plus minus plus Z alpha by 2 square root of variance of p. This I have written directly, but you can just follow the previous derivations, and based on the previous derivations, you can get simplified and we get. See what is the difference between these and the previous? There were It is small y bar and here small y bar. Only difference is this much. Okay. Now instead of small y bar, now it is p. And the whole derivations, whole confidence interval is same. Okay. Now again here you can do one thing. Here now I have just given for in general. I have given for in general. But in examination, if it is asked find confidence interval for the proportion P, for population proportion P under WR, तो आपको पूरा derivations as it is follow करना है. Okay. Plus you have to define what is your P and what is your variance of P. So variance of P we have just found here under WR. Okay. So under WR we have this variance of P. Okay. So you need to calculate. You need to show what is the variance of P. Okay. So that is you can always take care. Now, since there is one important note is that this may be noted that in the case of discrete random variable, so whenever we have a discrete random variable, so if it is discrete random variable, we have to approximate it by this continuous random. So whenever we do approximation, okay, when we do approximation, there will be some addition correction will be there. That is correction is n minus 2, and this correction we have to introduce in the limit, and finally we have to just use this. Just add here n by 2 and subtract here n by 2. This is just a to make, because we have defined here qualitative variable, right? And it is qualitative and we are converting it is, since we are using the z distribution which is continuous, so that's why we are just doing the end correction, which is basically adding 0.5 and subtracting 0.5, means you can call n plus n by 2 and minus n by 2. Okay. So any difficulty is there so far till here? You can ask. Let me see chat box also. Okay. So this is just a simple derivations. You can, once you write it down, because it is all done, all confidence interval, everything is done here. Okay. So I have not repeated as once again, because if I repeat it, it will consume more pages. Because it is similar to the previous derivations. So you can go for always the assuming the previous derivations. Now let's move to the estimation of sample size. So far we have not discussed about the estimation of sample size. We have done estimation of your parameter, then their variances, their mean, etc. But what could be the sample size? Okay, this is the very important part here. While planning any sample survey in any stage, generally we decide about the size of sample. Okay, we decide about the size of sample. So this size of sample, actually the sample size is very large, but it would be the waste of time and money, because if you have the very if sample size is very large, then obviously it will consume the so much time, your money, etc. other resources. Okay. On the other hand, if the sample size is very small, okay, if it is very small, it adversely affect the accuracy of results. The sample size small रहेगा तो आपका जो results है, you cannot generalize the result for larger sample. So accuracy of results is like it will affect in our results. So we must take the sample of optimum size, if there will be no rigid rule, means there is no fixed rule. There is no fixed rule for deciding the sample size. However, the following points must be taken under the account while deciding the sample size. So deciding about sample size is a very big, you can say, task, because if it is large, then it will consume a lot of time, energy, etc., etc. But if it is small, then accuracy of result is adversely affect. So we have to frame some rule of that. So there is a, actually they have mentioned there is no such a rule is there. So how? So what we can do in that case? Okay. So what we did here, we have given some notations. If you see these notations, we have given here population size, which is capital N, which we are already know, number of units in the population. Similarly, we have a sample size, that is total number of units in the sample. And these notations we have already done. Okay, these notations we have already done. So if you see this one, y bar is your population mean, and small y bar is your sample. Now here one thing we're defining here, 1 minus alpha, which is confidence coefficient in the terms of probability. You know this, I think you're knowing this one. Okay, so if I've just defined this probability value here, okay, so this portion here we have z, correct? So this portion basically your 1 minus alpha. Okay, so this portion is called as confidence coefficient. Okay, this is your confidence, how much confidence you have. So as the confidence increases, okay, as your confidence increases, you can say that your true value, the true value, that means your assumption is correct. So your population mean, which is belonging to that interval, is correct. Okay, so that is basically 1 minus alpha percent. And now here we have to define small d. Small d is basically called as error which can be tolerated. So to define something called error. Okay. So error is basically this remaining portion. If you see this remaining portion, this is the remaining portion which is called as basically alpha. Okay, alpha by 2. So this is basically a remaining portion. Similarly, this part is also alpha by 2. So this is the remaining portion which we have to tolerate and which we have defined it is D. D. Now what happened here, if we estimate the estimation of sample size for variance. Okay, so to obtain the sample size of small n under the SRS WR for variance, so we are considering for first we are obtaining the sample size under WR. Okay, then we will obtain the size under WO. So here I am already knowing this result. What is the result? These two results we already know. So no need to write a proof of this. We just simply write, we know that these conditions. So if you know these conditions, you can just say this. Okay. So again we are knowing this one. Assuming the last sample, we have small y bar follows normal with expected value of y bar and variance of y bar. And with the few derivations we did the last time, we know how it works. So this is equal to capital Y bar, and this is your sigma square by n according to these two results. One can write this one. And once it is Y bar, so this Y bar follows this condition. So one can write similarly SNV. I think this is, we have already seen how it works. Okay, so that is a very simple thing. So we are exactly doing the same what we did in the confidence interval. The only thing is that here the sample size we don't know. Okay, sample size we don't know, and we're trying to estimate the sample size. So how to get this sample size? So for that purpose, we are dealing with again the normal distribution. So normal distributions according to normal table, one can get this one. This is equal to 1 minus alpha. Now from here actually your main derivation starts. So if you see these concepts, here I'm just defining this z alpha by 2. This is the z alpha by 2. Z alpha by 2. So this z alpha by 2 is equal to t. So one can write minus t is equal to less than equal to z less than equal to t. So see, if you see the above expressions, here we have z alpha by 2. So that's why this I am assuming this is the small t. Now why we are assuming this is some quantity, okay, some quantity. Now can I write this minus t is less than z less than t is equal to mod of z is less than equal to t? Mod according to mod rule. Mod rule, what the mod rule says? Mod rule says, what does the mod rule says? If I have any value z less than equal to a, this can be written as minus a is less than equal to z less than equal to small a, right? Same thing you can write in terms of z, in terms of t. But what is your z actually? This z is equal to, I have just given the formula for z, small y bar minus capital Y bar upon sigma upon root n less than equal to small t. So what could be this one? If you just get multiply this quantity with sigma by n, what is next one? Just multiply this quantity with sigma by n. So what would be the result? Say this quantity will be 1. Okay? Say this quantity will be 1. Now, see very important part here. From the given conditions, on the basis of tolerance error D, we can say that, so this is the very important part which you have to always understand. So probability of this small y bar minus capital Y bar less than equal to small d. So this portion is basically your tolerance portion. Okay? This portion is basically your tolerance. So this we have to equate with d. Okay, and this is equal to 1 minus alpha. So equation using 1 and 2, equating them, we get d is equal to t into sigma by root n. So I'm just comparing these two results. Okay. So d is equal to t into sigma by root n. So from here you can just do some simple calculations like take root n this side, square it, and if you just square both the sides, and you just take some correction is this this square is not there. Just make these corrections. This square is not there. So root n will be taken here, and d will be this side. And then now you have to do square both the sides. So if you do square both the sides, become n, and this is sigma. This is t sigma d ka whole square. Okay. So this is the, I think, optimum sample size which is required for doing sampling. And if sigma square is known or sigma is known, then we will replace it by its estimate. Sorry, if sigma is unknown, if it is known, then there is no problem. But if it is unknown, then you have to replace their estimates. That is c square s square upon d, and where t is equal to z alpha by 2. So then case 2 we will do it later on. Let me ask if you have any questions. So if you have any questions, you can now discuss. Okay. Yes, any questions? No. No, why there is no questions? Means everybody is understood everything. No doubt at all. At any stage, at any step. I'm just scrolling. If you have any questions, you can ask. So hopefully today I will complete this unit. So I think uh, only the thing is that WOR is remaining. WOR is remaining, and based on the confidence interval. Yeah, I think. Yeah. So I will finish this remaining part in the at 4 o'clock lectures. If you have any questions, you can ask. There were one query that SRS WOR means efficiency between SRS WR and SRS WOR. See, that efficiency says which variance is less. Okay, so whichever the variance is less. So suppose I have a two variable x and y. Okay, so the variance of x is less than variance of y. So I will be say the variance of x is lesser than the variance of y. That means the variability in A will be lesser than the variability in y. That means your variance of x is more efficient the variance of y. Okay. So that's why WOR having less variance as compared to WOR. Okay. So that's why the WR is more efficient. WOR is more efficient. WR. Okay. Any other question is there? Everybody understood everything. No doubt at all. Great. Okay. So if we don't have questions, division A students can go because they have another lectures in another room. So division A students can go and rest can wait. So the other will join. Then I will make the host and leave. By the time we have any questions, you can discuss. Yeah, thank you because we are wishing a happy Teachers Day. Thank you so much. Do well, be safe at home, and be study. That is important. And I will not uploaded this. Let me see if GC. I think I have given the grade. So if the grade is assigned, you can will be notified. The grade will be there. So little. I'm going to just. I have uploaded yesterday's lectures on your YouTube, so you can watch it. That feedback form I will get at 4 o'clock. So you can give two lectures and you can submit.
पहले भेजना चाहिए था मैम ने सर नेक्स्ट लेक्चर वापस बोली ना अभी मैथ्स के सर को
So this is the last lecture video. So you can, if has not joined, maybe the internet issue was there, so you can connect via. अच्छा, ये डिवीजन बी वाले सब स्टूडेंट्स हैं ना यहाँ पे?